Example 4.2. A train traveling between two stations 5 kilometers apart completes the journey in 8 minutes. During the first 50 seconds, the train is moving with a constant acceleration, while a uniform retardation brings the train to rest in the last 40 seconds. For the remaining portion of the journey, the train is moving with uniform velocity. And we are asked to sketch the velocity versus time graph for the journey and also determine the uniform velocity, acceleration, retardation, and the distances traveled in the first minute and the last minute of the journey. Now let us take a look how are we going to sketch the VT graph for this train in this particular example. Now VT graph, all the information that you require can be found from the problem statement. So by reading the problem statement again, a train traveling between two stations 5 kilometers apart in 8 minutes. This information will provide us with the first kinematics quantities that we require to solve the problem. The displacement, the total displacement is 5,000 meters, which is in SI units, and the total time taken is 480 seconds, which is equivalent to 8 minutes. Now, the train, as what described in the problem statement, accelerates in the first 50 seconds, uniform acceleration. During the remaining portion of the journey, it maintains a uniform velocity. And at the very last 40 seconds, the train retards to a complete stop. And this is the VT graph for the train in this example. Next, we're going to solve the first quantity. The question asks for uniform velocity, which is this part here. So as you have noticed, we do not know the value of V, but we do know that the entire journey is 5,000 meters. And as what you have understood, the area under the VT graph is equals to the total displacement. And in order to solve the velocity V, we know that the area under the graph is 5,000. And this is a typical area of a trapezium formula. By applying the respective quantities A, B, and H and equate to 5,000, we will be able to solve for the unknown velocity V. Now, the question asks for acceleration. Where's acceleration? It is the gradient of the VT graph. So, acceleration is equals to final velocity minus initial velocity over the time taken. And plugging in the values, the velocity which we have found earlier, 11.49, which is the final, minus the initial, where the train was stationary, divided by the time taken, 50, you will get the acceleration of the train. Next, the question asks for the retardation during the last stage of motion, which is from the 440 seconds to the 480 seconds. So, retardation, basically this is the gradient that we are supposed to find. Retardation is also equivalent to deceleration. Regardless of the words that we're going to use, we will still apply the acceleration formula. A is equals to final velocity minus initial velocity over time taken. And for this stage of motion, the final velocity is 0 and the initial is 11.49 divided by the time taken, we will arrive to A is equals to negative 0.287 meter per second square. So again, it is negative. A negative acceleration implies that the body is slowing down to a complete stop. And finally, the question asks us to find the distances traveled in the first minute and the last minute of the journey. Now, the first minute refers to the first 60 seconds along the VT graph, and vice versa for the last minute refers to the last 60 seconds from the 480 seconds time frame. Now, the area under the graph, we know that it is referring to the displacement of the body in motion. And for the first minute, as highlighted in the green area there, this is the area of a trapezium. By applying the area of the trapezium formula, we can find the distance traveled. So we have half 60 plus 10 times 11.49, which is equal to 402.15 meters. In the same spirit, for the last minute of travel, same thing, apply the area of a trapezium, and we will find the distance traveled during the last minute of journey.